In episode 81, titled Runbooks, Turning Architecture into Repeatable Operations, we take the diagrams and design intent you already understand and translate them into something operators can actually execute under pressure. A runbook is where architecture stops being an idea and becomes repeatable behavior, the kind that produces predictable outcomes even when conditions are messy. In cloud environments, complexity hides in the seams between identity, networking, and automation, so operational consistency is often what separates resilience from chaos. The point here is not bureaucracy or paperwork for its own sake, but rather a practical guide that makes the correct action the easiest action when the clock is ticking. Before we continue, a quick note. This audio course is a companion to the CloudNetX books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good runbook captures the essentials that make an operational task safe and repeatable, starting with what triggers it and what must already be true before anyone touches a system. Triggers should be stated as observable conditions like a monitoring alert firing, a user impact report, or a specific threshold breach, because that helps avoid random troubleshooting rituals. Prerequisites include access level requirements, maintenance windows, dependency status, and any required tooling or approvals, because missing prerequisites is how well-intentioned actions become outages. Steps then move from preparation to execution to verification, and expected results are written as measurable signals that the change worked, not as vague feelings that things seem better. When these elements are consistently present, the runbook becomes a contract between design and operations, and it also becomes a reliable artifact for training new staff. When you write a runbook, assume the operator is smart, experienced, and currently stressed, because that is the realistic operating environment for most incidents and high-impact changes. Stress reduces working memory and increases the chance of skipping steps. So clarity matters more than elegance, and short sentences often outperform clever ones. Actions should be specific, bounded, and verifiable, so the operator can tell whether they did the step correctly and whether it had the intended effect. Checks should be placed immediately after the relevant action, not saved for the end, because you want early detection of unintended consequences. This approach also reduces thrash, where people bounce between systems without a plan, because each step has an immediate feedback loop that either confirms progress or signals a need to pause. Decision points are where runbooks become truly operational rather than just a linear checklist, because real environments frequently diverge from the happy path. A decision point should be phrased as a simple condition with a clear branch, where one path continues and another path stops or escalates, and the condition should be observable without interpretation. Safe stop conditions are equally important because they prevent the runbook from pushing an unstable system into a worse state by continuing after key assumptions fail. A safe stop condition might be a dependency still down, a security control not in place, or a verification check failing, and it should explicitly say what to do next, such as revert, escalate, or shift to an incident response path. By treating stop conditions as part of the design, you prevent the common pattern where an operator keeps going because they feel like they must do something, even when the right move is to pause and coordinate. Certain runbooks show up repeatedly across organizations because they map directly to the operational lifecycle of cloud services. Failover procedures exist because distributed systems and network paths fail, and you need a controlled way to shift traffic or workloads without compounding the failure. Restart and recovery runbooks exist because services freeze, memory leaks occur, and dependency chains break, and you want recovery to be deliberate rather than impulsive. Access change runbooks exist because identity is the control plane for most cloud platforms, and access drift is both a security risk and an outage risk when the wrong person cannot act or the wrong person can. Incident response runbooks exist because security events are not solved by creativity alone, and the first minutes require structured containment and evidence preservation. These are the patterns that let you build a runbook library that matches the realities of operations rather than the hopes of design. Embedding contact paths and escalation criteria inside the runbook saves time and reduces confusion, especially when multiple teams own different parts of the architecture. Contact paths should not assume tribal knowledge, because the person on call may not know which team owns the network gateway, which team owns identity, or which vendor portal holds the relevant support contract. Escalation criteria should be tied to impact and time, such as a defined number of failed checks, a defined duration of user impact, or a defined severity rating, because that keeps escalation rational rather than emotional. Including these details also supports auditability, because it demonstrates that escalation is a planned control rather than an improvisation. In practice, this is how you reduce the lag between detection and coordinated response, which is often where the biggest business losses occur. To make this concrete, consider a scenario where a virtual private network tunnel goes down and user traffic that depends on that tunnel begins failing in ways that look like a broad outage. In a cloud environment, the term virtual private network refers to an encrypted tunnel that connects networks securely, and it often anchors hybrid connectivity, remote access, or site-to-site integration. A runbook for restoring that tunnel begins by recognizing the trigger, such as a tunnel state alarm or a sudden spike in failed connections, and then immediately checks prerequisites like whether planned maintenance is in progress and whether a redundant path exists. The runbook then guides the operator through validation steps that establish scope, such as confirming which routes are affected and whether the failure is isolated to one region, one peer device, or one set of credentials. This initial structure prevents the operator from jumping straight into disruptive actions like forcing a rekey or resetting endpoints without understanding the blast radius. In the restoration sequence, the runbook should separate diagnosis from remediation while still keeping momentum, because mixing them tends to produce random changes and unclear results. It might instruct the operator to confirm that the tunnel endpoints can reach each other at the network layer, and then confirm whether authentication and key exchange are succeeding, because those are distinct failure classes with different fixes. If the architecture supports active-active tunnels, the runbook should include a decision point that checks whether traffic has shifted to the secondary tunnel, and if it has, the safe action may be to stabilize and schedule repair rather than force failback. If traffic has not shifted, the runbook can guide a controlled failover by adjusting routing preference or tunnel priority, with a verification check that confirms user traffic recovery and that telemetry shows stability. The expected result should be stated in observable terms, like tunnel state up, route propagation confirmed, and error rates returning to baseline, because those signals tell you the operation succeeded. One of the most common pitfalls is writing vague steps that sound reasonable but fail under scrutiny, like saying check logs without stating which logs, what time window, and what patterns or error codes matter. Vague steps create inconsistent outcomes because two operators will interpret them differently, and during an incident, you want convergence, not divergence. A runbook should specify what constitutes a normal entry versus an abnormal entry, even if it is described in plain language, because the operator needs a target to compare against. When you must reference telemetry, make it clear which metric, which threshold, and what direction indicates improvement, because otherwise the operator may chase noise. This level of specificity is not micromanagement, it is design applied to operations, and it prevents the runbook from becoming a collection of well-meaning but unusable reminders. Another pitfall is staleness, because runbooks diverge from architecture quickly when the environment changes but the documentation does not. Cloud systems evolve through continuous delivery, configuration drift, provider feature changes, and periodic refactoring, and a runbook that was accurate 3 months ago can be actively dangerous today. Stale runbooks often contain outdated names, deprecated endpoints, incorrect dependencies, or missing controls, and operators discover the mismatch at the worst possible time. The risk here is not just wasted time, but also incorrect actions, like restarting a component that no longer exists or failing to validate a control that was added later. Treating runbooks as living artifacts rather than static documents is a security and reliability requirement, not a documentation preference. A practical quick win is to store runbooks in version control, because version control provides history, review, and a disciplined path for updates that match the reality of change. Version control also makes it easier to associate runbook changes with architectural changes, so the runbook evolves alongside the system rather than lagging behind it. When you combine this with change management, you create an expectation that operational procedures are part of the definition of done for meaningful changes, especially those that affect availability, identity, or networking. Change management does not have to be slow, but it should be explicit about what changed, why it changed, and what the rollback plan is, because that context improves runbook accuracy. Over time, the combination of version control and change management turns runbooks into reliable operational assets rather than scattered documents that only one person trusts. Testing runbooks during drills is where you prove they work, and it also reveals whether the runbook is written in a way that supports stressed operators rather than idealized readers. A drill should simulate the trigger and walk through the steps exactly as written, because the goal is to test the procedure, not the creativity of the team. When a step is confusing, when a check is ambiguous, or when a dependency is missing, the drill should capture that as feedback to update the runbook immediately afterward. Updating afterward matters because memory fades and people rationalize gaps, but a crisp update while the experience is fresh keeps the runbook aligned with reality. This practice also builds team confidence because operators learn that the runbook is a trusted tool, not a suggestion, and that reduces hesitation during real incidents. A simple memory anchor helps operators recall the essential shape of a runbook even before they open the document, and it also helps authors ensure they did not forget a critical element. The anchor is trigger, steps, checks, escalate, document, and it reflects the operational flow from detection to action to verification to coordination to record. Trigger is the observable reason you are here. Steps are the bounded actions you take, and checks are the verification signals that confirm safety and progress. Escalate is the built-in path to bring in help based on defined criteria, and document is the record of what happened, what worked, and what must change in the future. When this anchor is consistently applied, runbooks across different domains start to look familiar, which reduces cognitive load and increases speed. Familiarity is not about making operations boring, it is about making operations reliable. A useful exercise is to outline a runbook skeleton from a described incident because it forces you to translate narrative chaos into structure action. You start by stating the trigger as a measurable symptom. Then you list prerequisites as concrete requirements, such as access, approvals, and dependency status, because those are the gates that keep actions safe. You then write steps with verification checks after each meaningful action, and you insert decision points where outcomes can diverge, including safe stop conditions that prevent further harm. Finally, you embed escalation criteria and contact paths so the operator is never stuck wondering who owns the next dependency or when the situation crosses a boundary. This skeleton approach produces runbooks that are consistent, testable, and easy to improve over time, which is exactly what a growing cloud environment needs. When you critique a runbook as a rehearsal, you are training your operational judgment in the same way that tabletop exercises train incident response instincts. A critique looks for specificity, clarity under stress, alignment with current architecture, and verification checks that actually prove progress rather than merely suggesting it. It also looks for places where the runbook assumes too much context, because assumptions are what fail during handoffs, staff changes, and major incidents. As you do this repeatedly, you begin to see runbooks as part of system design, not as an afterthought, because they encode how the system is intended to behave when things go wrong. In closing, Episode 81 reinforces that runbooks are the bridge between architecture and real-world operations, and a single thoughtful critique rehearsal is a small investment that pays back every time the environment surprises you. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.